I would like to express a warm welcome to those of you who have decided to spend your valuable time with us today. If you are a machine design engineer or an engineering manager in the machinery space, you know that your customers are making increased demands for their machines, looking for greater customization, ease of operation, integration to their customer plants and ecosystems, and increased machine reliability while lowering total cost of ownership. You also know that your competitors understand that they need to leverage tools to seamlessly integrate machine development silos of mechanical, electrical, software, and simulation into a single powerful engine of ingenuity. What we hope to accomplish in this webinar is to introduce you to a set of capabilities in the NX technology platform that will give you the competitive advantage you need to thrive in the rapidly changing world. One that is continuing to challenge your design tools and processes. So really the question is, have you moved your design and engineering technology to the next generation? Today, in many companies, engineering processes are fragmented silos of specialization. Critical information often falls through the cracks between these different disciplines. Project schedules are usually sequential and open loop. The tools that each group uses are not integrated. Manufacturing is typically under extreme pressure with late changes and poor handoffs to commissioning. We believe that single discipline tools and isolated processes are insufficient to deal with the complex nature of engineering challenges in today's machinery world. The next generation of design integration requires a single environment and an integrated solution. The machinery world has evolved very rapidly, especially in the past several years. Let us consider this machine, for example. Beeler has manufactured machines used in the metal processing industry for over 60 years. They have several machine platforms that provide multifunction stamping, forming, and welding operations. Beeler understood that for it to succeed, it needed to provide more complex, multifunctional, and incredibly sophisticated machines. These machines would dramatically change their industry, performing more functions with faster changeover times and far greater integration of electronics and machine control technology. Today, Beeler is the leader in the industry and an undisputed master of innovation. It invested in taking its design technology to the next generation. As machines get smarter and manufacturing technology is transformed, the next generation of design engineering takes advantage of digitalization and drives your business forward. How do you become a catalyst for change and help your customers take advantage of these trends? The machinery companies who build and service the most automated, flexible, connected, and adaptable machines are the ones that will define the future. Let me share some of the ways machinery companies are working today to increase their competitive advantage. One way is by increasing flexibility by adding capabilities to existing machines, adding automation and software-driven mechanisms. Even historically mechanical and pneumatic systems are becoming replaced with electronically controlled functionality. Another way is through increased connectivity. IIoT is combining smart sensors and cloud analytics to help build machine intelligence, enabling machines that adapt to their environment. And finally, companies are building strong, intense partnerships with their customers. These partnerships not only solidify traditional business models, they are also providing new business models, including subscription or production as a service opportunities and other innovative software-enabled service monitoring and machine optimizations. When we look at the industrial machinery landscape, we continue to hear from our customers that there are several transformational trends that mark a significant turning point in the machinery evolution that are currently reshaping the engineering, manufacturing, and service operations for most machinery manufacturers. There is a marked shift toward personalized products and customized services, and machinery companies are challenged to design and build machines that support expanding product mixes and more rapid and frequent changeovers. And because consumer preference changes are more immediate, there is added pressure to innovate quickly and compress delivery cycles. Industrial component suppliers are quickly embracing IoT-enabled technology in their products, and machinery manufacturers are on a steep learning curve to take advantage of the petabytes of data that can be generated from today's machinery. This has rapidly changed the landscape for electrical and controls automation engineers, from huge increases in I/O channels, new communication protocols like 5G, and to build intelligent programming that provides more interactive and granular control of all of these devices. At the same time, there are insights to be gained from so much information that can be handled by the automation and production processes. The trend of hyper-automation requires vast amounts of data and cloud-based analytics to accelerate learning about machine behavior and performance to automate machine functions. But adding sensors may not be enough. You need to have the capabilities to analyze the explosion of complex data you are monitoring. Hyperautomation is also enabled by low-code tools that can mine data analytics from any business processes, manufacturing optimization, as well as engineering reliability and cost reductions. And finally, global competition has always existed. But now, the competition comes from more flexible and agile startup companies that start from the basis of machine learning and are not encumbered by the existing business processes and legacy customer engagement. In many cases, the aging workforce in many parts of the world has forced employers to replace experience with machine learning, and many machinery companies may not survive this transition. Understanding your customers and the efforts to their trends and market drivers can be overwhelming. But in reality, the challenges of the machinery industry, whether it's an OEM or supplier or downstream customers, can be summarized in one commonality: complexity. And the true disruptors in our industry won't be those trying to limit complexity. We believe you need to move faster to bring innovative machines to market faster than your competition. You want to lower development costs and decrease production and operating costs. You also need to create new business models and out-innovate, building differentiation through insights that are not easily duplicated. Well, we believe that the businesses that succeed will be the ones that embrace complexity within our industry and harness this complexity into their competitive advantage. We believe that the true leaders in the machinery space, the true disruptors, will embrace three key concepts in order to turn complexity into their competitive advantage. The most comprehensive digital twin. With insights and data from a comprehensive digital twin, companies can very accurately simulate performance of their machines, allowing them to build more flexible and connected machines to handle a wider range of products, enabling quicker responses as consumer preferences change. Any part of the real product or production environment that isn't represented in the digital twin can't be simulated, introducing risk into your business. Modern, adaptable, personalized solutions. You must be able to provide people across your organization with the tools that are easy to use and able to pull information from many places and present that information to them in a way that is consumable for the task they are trying to complete. Making data available isn't helpful if it's presented in a confusing or complex way. It must be personalized to the person and their task. And a flexible open ecosystem. Information technology plays a critical role in the pursuit of complexity as a competitive advantage, and no one tool or vendor can do it all. If the tools you choose don't work well together, your pursuit will fall well short of your goal. Where we can help you is through the application of our accelerator portfolio. This is our integrated portfolio of software, services, and application development that encompasses all of Siemens software products and technologies. Accelerator is the technical software foundation of a company's digital enterprise that enables continuous ingenuity in product performance, product development, product operations, and lifecycle support. It is comprised of multiple applications and solutions that manufacturers can utilize to address their most pressing challenges. Accelerator can also be personalized and adapted to fit customer and industry-specific needs to help companies of all sizes become digital enterprises. And we've done exactly that to create specific industry solutions for our industrial machinery customers. By leveraging Accelerator, you can embrace complexity to achieve competitive advantage and be well positioned to meet tomorrow's challenges today. Our mechanical solution is driven by NX, which allows you the most complete 3D design solution available to drive your digital twin. Your digitalization strategy needs to include consideration for the whole machine. You now have a seamless connection that spans from theoretical concept to machine assembly, through operation, upgrades, and ultimately to end of life of machine. All of this is based on a single model and eliminates the needs to re-enter data into other systems. With this, you will have the most efficient, accurate business process. The digital twin allows you to lower your cost to manage your intellectual content. With all of the information that is now available, you can manage the cost across assemblies, part manufacturing, and commissioning, which allows you to maximize revenue with proactive service, replacement part response, and upgrades to your machines. Siemens Digital Industries Software is the undisputed leader in the ability to deliver the digital twin. We do supply the world's most comprehensive digital twin. This will allow you to break down the silos and have a true multi-domain coverage with closed loop to performance engineering and automation, which significantly improves quality and decreases time to market, and extends the digital twin beyond just design for consumption across the entire enterprise. The foundation of the digital twin is the digital twin of the product. The creation of that digital product starts with NX. NX is the next generation design platform where engineering meets tomorrow. NX has all the tools to allow you to create the most comprehensive digital twin. Seamlessly combining multiple disciplines, NX enables more iterations by both experts and non-experts and utilizes the latest manufacturing and simulation methods to ensure you recognize the value of digitalization and deliver the best designs to market faster. You need a single platform that contains all the tools to break down the barriers between disciplines. NX allows all of your engineers and designers to collaborate and share information across traditional boundaries that exist in single discipline solutions. The NX platform allows your enterprise a complete solution that takes advantage of the data without having to remaster that data in other systems. We at Siemens Digital Industries Software are here to help you reach your goals. We have the tools to help you break down the barriers to innovation and fulfill your digitalization strategy. These tools fall into 6 areas that you will need to address. They are using the world's most productive modeler, moving to an electromechanical design tool, being able to bring simulation and manufacturing teams into the design process at an earlier stage, managing the entire process and data across multiple domains and disciplines, harnessing the power of the computer to produce your designs based on a set of key inputs and outputs, and embracing additive manufacturing for use as more than just prototyping. To do all this, you need to embrace a multidisciplinary platform that can serve the entire enterprise. Our ongoing commitment to core modeling technology investments provides the world's most productive modeler. Productivity of our tools has a huge impact on your ability to quickly execute projects and minimize time spent on data maintenance and change management. We at Siemens believe in making our tools the most innovative tools in the market. In fact, over the last 2 years, the NX team has been granted 66 patents that will help you move forward with increased productivity in your workflows. The world's most productive modeler has an intuitive, interactive user interface and the fastest model resolution to help you go from concept to model reality in the shortest time possible. Let us take a look at some of the keys to this technology. Siemens is changing the world of sketching by making the biggest change to the way people sketch in over 30 years. With our latest sketch capabilities, we relooked at what you wanted to achieve, and we are delivering a new approach to sketching that has already been shown to reduce time the users spend capturing their ideas by over 30%. And when you consider that for many users as much as 15% of the day is spent sketching, that's a significant improvement in productivity. In the brand new NX Sketcher, you will notice that we rely mostly on curves and dimensions to drive and fully define your sketch. We will start with a simple rectangle, and from there we will move the rectangle over by relaxing one of the symmetry relations that is found in the sketch. Then we will continue to add our geometry to the sketch as needed. We will add the diamond around the center of the shape. We did not quite get it right, but no problem. All we need to do is to drag one of the endpoints onto the center line and snap it there, and now we have a perfect square. We continue to use dimensions to fully constrain our shape. We never need to add relations as the sketcher finds all of them for us. We will go ahead and draw in some of the curves we need for the pockets in our bracket. Next, we will add some more lines, and then we will dimension these entities as to fully define our sketch. Notice the curves turn from brown to black as they become fully defined. We trim away the unneeded curves to create our pocket by simply dragging a few of the curves. We see we have a couple of curves that are not yet fully defined. Adding dimensions, we know that we have a fully defined sketch and everything is black and we cannot drag the curves. If you want to see how certain things react, we simply relax the dimensions. The pink numbers are the ones that need to change to accommodate our design change. We will quickly finish the design by adding a circle in the middle. The fully defined sketch is complete. All we need to do is use this single sketch to create three different extrusions. One symmetric for the entire rectangle from which our bracket will be made. Next, the second extrude, we will use the top half of the connected curves to eliminate the top portion of the arrowhead. And then finally, we will pick the circle and use a bounded region to cut out the bottoms to make a hollow through our bracket. Once the extrusions are complete, all we need to do is to add a couple of blends to the sharp corners, and we have completed our bracket in just a few steps in a short amount of time. You can now design your machine support structures in a fraction of the time. Being able to design structural frames in minutes means faster time to market, ensuring accurate and realistic structure designs based on industry standards with more time for making quality-driven iterations. Finally, downstream documentation tools enabling multidisciplinary collaboration across the enterprise with your suppliers. What we see is how we can quickly build a structure around our machine. We will start with a simple wireframe design of the shape we need, in which to encapsulate our machine. A box is drawn, and we will add a few more lines where we would like to put some support members. This is a quick and easy way to get the shape we need for our machine structure. After we have drawn the wireframe of our structure, we will start to add standard members to all the lines we have drawing. Simply by picking standard sizes that we have in our library, we pick the different lines for different members. You will see here we are quickly adding to the outside of the structure right away. Notice it is as simple as picking the lines and assigning a member to it. In addition, notice as we do this, the corners are automatically being trimmed back to their correct size and locations. For each wireframe line, we can combine different members in different orientations as we lay them out into our design structure. The ability to edit wireframe location is also available. The corners can be quickly adjusted based on which ones are first and where we want the overlaps and the formats of our corners. Complete control is accessed with the lineup points of how we would like our members to line up in the context of the existing structure, and we immediately get feedback as to where it will fit within our structure. All of the corners have multiple different kinds of options we use to order the overlaps. Now that we have a good basis for our structure, we will continue to move on with the design tasks. Not only can we just use to design the structure, we are now in the context of the structure and we are going to place a mounting plate. The mounting plate will need to be reinforced with gussets. The mounting bracket is placed into the structure, and within the context of our structure designer, we place a couple of gussets between the existing structure and our bracket. The gussets were needed to give us the required support for this mounting bracket. Again, we are using standard sizes from our library of parts. This helps us make sure we are reusing standard parts that we have in stock. Now that we have all the parts in place, we simply need to cap off the tops of our structure, and we quickly have, in a matter of minutes, completed our structure design. We can now go ahead and see how we can make changes to the underlying wireframe we started with to update the structure. Finally, we verify that the structure fits into the context of our existing machine. Synchronous technology allows you to edit your data no matter where it comes from or the current state of your models. You have the ability to make changes on models that have no history at all, or history-based models that have not taken into account the needed design changes. We will now make some changes to the part in our assembly. While working in the context of the assembly, the first thing we need to do is move over the entire mounting hardware for our HMI. After we do this, you will see that the mounting bracket to the cabinet is no longer attached. We need to adjust the mounting bracket. We will move the face and have NX find the related offset faces and move that face to be even with the edge of the subassembly we moved. Notice that synchronous technology automatically adapts the blends along the way. To continue, we will move on to the sheet metal part that encompasses the movements for our bottling machine. In this example, we will start with the slot on the top. Notice a couple of things we can do with the slot. The first is that we can very simply just move a single face by saying move face, and we pick the face and the blends on the corners are automatically adapted. But let's say we want to move the entire slot. So instead of telling synchronous technology to pick a face, we tell it to pick a slot, and it figures out what a slot is, and then we drag it to its new location. We will now move to the bottom of the cable tray and add some more material to it. So what we will do is we will select all the faces on one end and then simply move them over to give ourselves more length in the cable tray. The last changes we will make are with the holes in the part. First, we will delete one of the holes. Then we will pick one of the holes and find all the diameters for that hole that are near and far and symmetric. We will adjust them all in one easy command. Synchronous technology found all the holes that were the same diameter, and we were able to easily change them. If we look at our model tree now, we can see the beauty of synchronous technology is that it creates the features that we can change moving forward in our design process. Rami is a machine building company based in South America that recently moved from SolidWorks to NX. They faced many challenges with their old solution, including incorrect BOMs and just the ability to open their data completely. Let us see what NX brought to Rami. Rami was able to reduce their overall MCAD seat count by 30%. In addition, the teams can work on the same model at the same time and do it in the context of the complete assembly. They have increased data reuse by 20%, which not only helps reduce time to market, it also contributes to increased profits since the company does not have to take out new part numbers. And all of this helps Rami capture their best practices and now apply them to all of their projects. The world's leading multidisciplinary design platform. NX enables a multidisciplinary approach to machine design that breaks down barriers between electrical, mechanical, and automation engineers. Mechatronics design continues to revolutionize the machine design process by helping you design faster with higher quality and provide an end-to-end solution that embraces multidiscipline collaboration, reuse of existing knowledge, and reducing time to market by making better decisions throughout the concept to production evaluation. This will allow you to move your organization from 3D to mechatronics in the same way you moved from 2D to 3D decades ago. Smarter machines are needed to achieve higher throughput and higher accuracies. This simply cannot be achieved mechanically and needs integrated mechanical, automation, electrical, and software technologies. So, this bottle testing machine is a perfect example of how Siemens is the vendor that can deliver all of the components needed for machine design, hardware as well as software. Mechatronics Concept Designer connects to other products in the Siemens suite in both the areas of software and hardware. Mechanical design can be integrated with sensors, drives, actuators, and HMIs. As a result, sequences of operations are created and can be used, for example, by Siemens Motion Control and Siemens Factory Automation products. Customer requirements can be verified against your design early on to validate that the solution will work within the context of your existing design. The most optimal concept that is now validated can be chosen and reused without the need to re-enter any data into the final machine design and save you time to market and delivery. In this example here, we see that we need to develop a system that can test bottles across a different set of requirements, from a single-size low-speed line all the way to multiple-size bottles that run at high speed. We can validate our performance digitally across all of these multiple use cases, and once the filling system is validated, it is simply brought into the machine at the assembly level without having to re-enter the data. This helps you save time and eliminates errors during your engineering process. Tranrud is a machine builder based in Norway. They have a long history of building automation machines for the packaging industry. They needed to be able to reduce their development time due to an increase in global players. In addition to be able to accomplish this, they also needed to reduce errors at the commissioning phase. These errors included collisions that were being found during the physical commissioning state. Tranrud reached out to Siemens Digital Industry Software to help solve these issues. And with the combination of NX, Mechatronics Concept Designer, and TIA Portal, Tranrud was able to cut their production time in half. A big contribution to this was that they spent 25% less time on commissioning, and there were no physical crashes once they started commissioning, since they had resolved all of them with the digital twin during virtual commissioning. NX has a complete set of simulation and manufacturing tools to cover all levels needed for everything from the designer to the expert levels with these tools. Break down the barriers to validation by enabling the design team to analyze product performance early in the concept and design phase. This allows faster iteration of more possible solutions. In addition, you can introduce manufacturing into the process at an earlier point to make sure that all of the material can be produced to help compress delivery times. All of this can be accomplished with a single master model that keeps everything up to date. Animation Designer is a designer level tool that provides a starting point to a scalable solution that can be used up to Mechatronics Concept. Let us now take a look at Animation Designer. The designer level tool to be able to quickly set up motion studies in your design. This motion can then be moved into NX Mechatronics Concept Designer, MCD, that we saw earlier. In our first study, we want to look at the ejector position and see how it is reacting, making sure that we have all of the motors properly defined. Now that we have verified the ejector position, now that we have verified the ejector piston, we will go ahead and look at the bottle filling mechanism. The nice thing here is that we have multiple movements all at once, and we want to be able to go ahead and track the distance of the filling head to the belt. As we see, our machine moves through its cycle. It is giving us feedback on the distance we are interested in. In addition to getting automatic feedback, we can now start to graph that feedback and capture these graphs and then use them for further engineering studies or validation. Before we go ahead and complete our design, we want to take a look at other values for our motion. We will set up more monitors to be able to graph multiple functions all at once in the context of our movement. So what we will do is pick the motors we want and the parameters we want to track. We simply run the simulation again, and notice we get a nice graph for multiple values. We can then save out these graphs once we're done running our simulation. Now let's look at each motion individually. We are doing this to check the limits of our movement for each motor and validate that we have the right amount of motion for each individual motor and joint. Here we can independently validate the limits of our motion. This allows us to be able to validate our design early on in the design phase before moving on to the complete digital twin without the need to re-enter the data for downstream application. NXCAM provides advanced capabilities across key industries and machine technologies. High-speed machining and 5-axis machining capabilities are provided along with CAD and assembly functions. NXCAM's master model concept keeps the assembly and toolpaths associated to your source model. Using the master model concept, you can edit the part for better manufacturability without editing the source model. Master model capabilities ensure that the NC programs stay associated to your source model. Synchronous modeling, as we saw before, is a powerful method for directly editing solid faces. It is also available in the NC environment. Developing as-cast models or other derivatives from the existing parts is easy since the programmer simply needs to push or pull existing faces, close holes, or even delete features. NX provides adaptive high-speed cutting strategies that help you achieve a new level of machining efficiency. Adaptive milling, an advanced roughing method, enables deep cuts and a consistent tool load, resulting in high material removal rates, ideal for cutting hard material, as it reduces heat generation and vibration in the cutting zone, which in turn reduces tool wear of the cutting tools, extending those tool lives. Adaptive milling is available as a 3 or 5-axis operation. 3 and 5-axis adaptive milling enables for high-speed material removal rates. NXCAM also provides extensive fixed-axis cutting capabilities for complex surfaces such as those found in mold and die applications. The functionality enables you to achieve the smoothest tool path results in steep areas by outputting a smooth helical tool motion. NXCAM invokes automatic tool tilt as a reaction to the tool holder collision in deep cavities or by steep walls. Tilting the tool to provide clearance for the holder enables cutting with a shorter tool and higher feed rates. NX provides tool paths that flow organically with your part. With these smooth patterns, you can interpolate guide curves for the smoothest finishes. You can even cut true 3D spiral patterns with no step-over marks. High-speed machining maximizes CNC machine investments. Smooth cutting patterns for the highest quality surfaces. PM Bearings is a company that designs and manufactures high-precision bearing systems for customers that require micron-level tolerance in strict regulatory environments and where novel solutions are needed to meet unique customer demands. PM must engineer the solution, simulate it, and validate it prior to cutting a single chip. As PM Bearings was moving forward from a component supplier to a complete system integrator, they needed to update their engineering software, and they looked to Siemens. And by combining design, simulation, and manufacturing all into NX, they have been able to reduce their error rates and downtime, and getting designs out the door even faster. Collaboration across engineering, manufacturing, and service operations connected to industrial IoT. By leveraging Siemens' digital innovation platform, collaboration between traditionally disparate groups is increased, transparency and efficiency, all while quality is increased while being able to provide the right information to the right group at the right time. Specifically, machinery is an industry where the engineering process is a mix of configure to order and engineer to order. But in the last years, there is a shift more towards the engineer to order to support the production of one-off machines. The challenge here is to lower the cost of these customized machines through a modular design platform and a solution that can support this platform. The level of standardization capability for your business is highly variable and depends on your customers and the industries you serve. Generally speaking, you can decrease operating costs if your product is highly configurable but uses consistent manufacturing processes. Machines that are more modular can be combined in multiple ways, providing additional value at the assembly or subassembly level throughout part reuse. The overall key to profitability is configuration management. There is no doubt that advanced visualization is a benefit to the machinery business. The complex integrated nature means that the single view of the machine through 2D drawings or photo-driven operator and service manuals is inadequate to communicate the needed information inside and outside of the organization. Here we will see how NX Virtual Reality, you can step right into a machine to get a better view of what is happening. We start out the session by starting NX Virtual Reality. The biggest benefit to NX VR is that you do not need to maintain another set of data. The NX data is used directly in the virtual reality environment. This gives us the ability to do things like section the model, get model properties, and take snapshots that can then be passed back to our NX design team for review. In this session, you will notice a few things that need a design change. So we will create a markup and then notify the design team to take a look at this issue and make sure we get this issue resolved before we move into production. In addition to design reviews, we can also now start to use NX Virtual Reality for serviceability, where we can train our service teams up front before they go out into the field to make sure they understand what parts they need to replace and what the inside of that machine may look like once they get out into the field. Bausch & Strobel is a German company that creates packaging machines for highly regulated industries. They are seeing increased demand from their customers to bring their machines to market faster. They adopted a complete digital twin with the help from Siemens and to leverage animation of the finished machine to prove to customers the viability of that machine in their plant. It is a key to their success that they can integrate the CAD models with the control software to provide real-time machine operation. This improves the customer experience through the build process and helps ensure that the right performance level is delivered the first time. Generative design helps you quickly find the optimal design, while powerful simulation and validation tools enable a complete engineering toolset all in one place. Man-made designs tend to have a lot of straight lines and simple curves. They are constrained by a number of factors, including manufacturing techniques, aesthetics, material availability, and others, but they are not necessarily optimal. Natural designs, however, have been shaped by natural forces to conform and to adapt to their environment. It may not look like they're optimized, but they are really optimized for that environment. Generative engineering is a paradigm shift in the way products are designed. Instead of starting with a design and then verifying its performance against requirements, the process starts with the specification of requirements, constraints, and context. Simulation and artificial intelligence-based methods are then used to generate innovative designs, allowing for shorter cycles. What strongly differentiates our generative engineering approach from others is its applicability to system-level architecture and its ability to do optimization across multiple engineering disciplines, not just mechanical. Let's see what HP was able to do with generative engineering. In HP 3D printers, in order to keep the print head from overheating, an air duct is installed right over the printer head to deliver a specific amount of air. Not being able to provide sufficient cooling to the printer head will either decrease the lifetime of the printer head or degrade the printer speed. How could HP have been certain that the duct they developed will be the most adequate shape to deliver the highest airflow possible? The following video shows the CFD-based topology optimization process of the cooling duct in order to find a design that maximizes airflow through the duct. You can see that the baseline design is characterized by a strong swirling flow, which is of no benefit to the desired directed air through the duct. Without going through too many technical details, what is happening here is that we are converting local areas that have a negative impact on the overall flow rate by solidifying them. As such, the topology of the airflow path evolves, improving the flow rate with every iteration. The result is a duct shape that has a quite organic appearance and would have never been considered if using a traditional engineering approach. The airflow itself became the designer and ended up being increased by 22%. In addition, HP was able to recognize a part cost reduction and was able to develop the new part faster than using traditional methods. Reimagine products, reinvent manufacturing, and rethink business. Additive manufacturing is about more than just 3D printing of parts and prototyping. It can be a launchpad for you to reimagine products, reinvent manufacturing, and rethink your business. Siemens is the one solution provider that has all of the tools needed to adopt additive workflows. We have the ability to use the same data without translation across the entire process. This movie shows how to create a new part that solves a particular function and optimize the mass for the part, which leads to the ability to increase the speed of the machine by lightening up the part. This new back bracket can be produced using additive manufacturing techniques, or you can use this shape as a starting spot to create geometry that can be made using traditional manufacturing methods. Here we are, once again, using designer-level tools, not high-end specialized tools, to create these brand new shapes. In NX, designers can harness the power of a combination of technologies, including traditional feature modeling, advanced modeling tools like NX Realize Shape, and new technologies such as topology optimization and convergent modeling to reshape existing products and develop the next generation of products. The example here is of a redesigned burner tip using these new technologies that achieved a uniform distribution of the cooling water and reactants from pipe inlets to ring-shaped surfaces over a short part height. In comparison to the conventional burners, the redesigned burner tip enabled a simplified assembly by using pipe connectors instead of nesting ring-shaped channels. Toolcraft is a pioneer of forward-looking technologies, such as 3D metal printing and the construction of customized turnkey robotic solutions. Toolcraft tests and develops innovative engineering processes for use on production lines. They are a supplier of high-quality parts to various industry OEMs in the medical, automotive, aerospace, electronics, and other industries. When Toolcraft started to use additive manufacturing, they had to be able to use up to 4 different software packages to get the results their customers demanded. Toolcraft then turned to Siemens, and to be able to get one software solution to cover all of their process needs. They have been able to reduce errors and rework, all while making changes at a rate faster than ever before. Next generation design is allowing engineers to increase their productivity substantially by using NX. We have and will continue to develop the world's most productive design tools. Our solutions enable true multidisciplinary design so you can include your entire engineering team to work concurrently. We have the ability to access one data source across all of the areas needed to complete the design, from design to analysis to manufacturing. Streamlining engineer-to-order and configure-to-order processes across the enterprise while retaining essential component organization. Harness the power of the computer and machine learning to complete your design and meet all of your requirements. And take advantage of emerging mainstream manufacturing technologies to provide novel, cost-effective solutions. Nextrum, based in Austria, had over 50 years of continuous improvement and believed they could not get any more improvements into their process. Then they reached out to Siemens to adopt the digital twin further into their process and have now been able to reduce their time to market by 50%. Let us see what we are doing to make our solutions more adaptable, personalized, and modern for our customers. First, we leverage machine learning to accelerate design and learning with our new adaptive user interface, which makes the design process more efficient by being able to predict the next command you will need. We are bringing new, exciting, and creative ways for our customers to use AR and VR across a large set of workflows. We are also working with our software applications to adapt and personalize user interactions. NX provides a personalized expert assistant. It collects data while you interact with the system. It provides the best choice or set of choices based on what you have done. With 95% accuracy, Adaptive UI tailors the interface to show different levels of complexity for different levels of users. Recently, NX was shortlisted for a Corporate Innovation Award judged by Iconics. Companies are trying hard to differentiate their products through additional features, quality, cost, size, and weights. How can a single flow satisfy all of the customer needs? You need to be able to offer something that is unique, open, and integrated. Siemens' embracing of an open architecture is the key to be able to meet these goals. NX is the only major MCAT tool that has been certified open by ProStep. We at Siemens are adopting our business flexibility to meet your demands, not ours. We provide both perpetual or subscription licenses, and we can deploy them in a multiple of different ways, from on-site through cloud-based, or a combination of what makes sense to your business to move forward to get the best return on your software dollars. What happens to companies that fail to embrace digitalization? They fall behind the fast pace of technology disruptions that can make products and businesses obsolete. We can help you digitalize your business to realize product innovation by bringing together your entire product innovation process, people and information across departments and disciplines, including partners and suppliers. We can help you manage and optimize your entire product lifecycle. The path to digitalization begins by taking a new approach to your entire engineering processes. Work with us and we can show you the way. To summarize, our strategy for NX is to deliver world-class engineering solutions that enable you to build the most comprehensive digital twin of your product, allowing you to integrate across engineering disciplines with closely connected processes that help you build and reuse the digital twin. To give you the most personalized and adaptable solution that meets your needs and grows as your use of NX grows, using solutions like machine learning and artificial intelligence to deliver a truly personalized experience based on your workflows, and leverage our open ecosystem, including our component technologies like Parasolid, JT, and NX Open, to allow solutions to share information across the enterprise, giving you the maximum opportunity to leverage the comprehensive digital twin. And with that, I'd like to thank you for your time, and I want to ask you again the question we started the day with.